Hello, Namaskar and very good afternoon to all the viewers connected with us on NCERT's live and interactive program. I am Manodarpan, your host for this session. Dear viewers, you are catching us live on PMA Vidya channel number 11. And apart from this, we are also streaming live on our YouTube channel which goes by the name NCERT Official. You can become a part of our live interaction by sending in your queries, questions and answers on the live chat box of our YouTube channel. Our experts will be more than happy to give answers to all your queries. So dear viewers, for this 1 hour, we are connected with you for class 11 and subject would be physics, and the topic that we are bringing to you is Introduction to Scalars and Vectors Part 1. जी हाँ, ये पार्ट 1 है दर्शकों और जल्दी ही हम पार्ट 2 भी लेकर आएंगे और इस पार्ट 1 को हमारे साथ लेकर जाने के लिए जो एक्सपर्ट जुड़े हैं, आइए उनसे मिलते हैं. द टीचर, द एक्सपर्ट who is going to teach this topic is Mr. I.K. Gogia. Sir is former PGT Physics from Kendriya Vidyalaya Sangathan. Very welcome to the session, sir. नमस्कार.
नमस्कार, थैंक यू.
दर्शकों, अगर आप हमसे टेलीफोनिकली भी जुड़ना चाहते हैं तो आप हमें फ़ोन नंबर भी नोट कर सकते हैं. इस समय हमारा फ़ोन नंबर फ्लैश हो रहा है स्क्रीन पर और हमारा फ़ोन नंबर है 8800440559. Apart from that, if you wish to write to us in detail, please note down our email address also. It is dth.class11@ciet.nic.in. Also, I would like to welcome our Indian Sign Language interpreters also. As you can see, Miss Naina is interpreting the entire session for you, and soon we will be joined by Miss Disha. Namaskar to both the interpreters. All right दर्शकों, जैसा कि मैंने आपको अपने टॉपिक के बारे में बताया, एक बार फिर मैं बता देती हूँ. इंट्रोडक्शन टू स्केलर एंड वेक्टर्स पार्ट 1. आखिर होते क्या हैं स्केलर एंड वेक्टर? आई थिंक दीज आर दोज क्वांटिटीज विच कैन बी मेजर्ड लाइक हाइट, फोर्स और मे बी वेट एज वेल, एंड दीज आर ऑल कॉल्ड फिजिकल एंटिटीज. और फिजिकल एंटिटीज को हम दो तरह से डिवाइड कर सकते हैं, स्केलर और वेक्टर. इन्हीं सब बातों को डिटेल में बताने के लिए आइए चलते हैं हमारे एक्सपर्ट के पास, श्री I.K. गोगिया जी. सर,
We will be in this today's lesson. We will be talking about physical quantities, the scalars and vectors. That this is classification of the physical quantities. Graphical representation of vectors. We can represent vectors by means of a diagram. This is what we will study. We will differentiate between distance and displacement, and also talk about position vector and displacement vector.
जी.
Physical quantities first. Physics essentially is a science of measurements.
Right.
When you study physical phenomena but don't measure anything, for example, talk of temperature or talk of pressure, if we don't measure it, it means we are just partially talking about these things.
Right.
So measurement is extremely important in physics.
जी.
So all quantities which can be measured are called physical quantities, and the list of physical quantities is very long. Some of these you have already given. Here is a list which contains some of the physical quantities: mass, length, time, distance, speed, force, velocity, displacement, acceleration, weight, temperature. In addition, we have current, voltage, etc.
Right.
All these are physical quantities.
quantities.
Whatever we can measure is a physical quantity.
जी.
We classify physical quantities into scalars and vectors based on their nature, as will be clear in a minute. Scalars, the physical quantities which are completely expressed in terms of their magnitude alone, they are called scalars. They do not have any sense of direction included in the in their measure. For example, temperature has nothing to do with direction.
Right.
Time has nothing to do with the directions. 2 seconds is 2 seconds, 1 hour is 1 hour, north, south, east, etc. They are ruled out here. So such quantities are scalar quantities.
Right.
You have a list of scalars examples on the screen: mass, length, time, distance, speed, temperature, etc. These quantities, as I said earlier, do not have any associated direction. The magnitude of these quantities may be positive or negative as per some standard convention.
जी.
Scalars can be added or subtracted by simple algebraic rules. For example, you have 2 kg sugar, add 3 kg more to it, you get 5 kg.
Right.
Similarly, you have a length of 7 meters, say 7 meter long cloth, you cut off 4 meter from it, you are left with 3 meters. So, simple algebraic addition or subtraction works for scalars, not for vectors, as we will see later.
So, here I would like to ask a question, sir. Since we are building on the magnitude and I could see different units being used here like kilogram and meter. If you could explain a little bit about magnitude, what do we understand by magnitude?
Magnitude means how much is the physical quantity. For example, the room in which we are sitting, if you measure the length of the room, what you will do is you will take a meter,
right,
and see how many times meter is contained in the length of the room. 1, 2, 3, 4, 5, 6, say 7 times meter is contained in the length. We say that magnitude of length of the room is 7 meter. That is what we mean by magnitude.
All right, okay.
So, vectors are physical quantities which need both magnitude as well as direction for their complete specification. Force, velocity, displacement, acceleration are some examples of vectors. We use bold italics to represent vectors. These are the symbols which we use. Alternately, we can also put an arrow on top of the physical quantity. For example, F with an arrow on top also represents a vector.
Vector, right.
Force is a vector as its effect on a body can be known only if we know direction in which the force is acting. If you apply force on a block towards right, it is different from applying force on the block towards left.
Right.
You can see in this diagram, see, here we have a block and we are applying force towards right.
Right.
So, it will move the block towards
right.
So, force will produce an effect depending on its magnitude as well as direction.
Right.
So, force is a vector quantity. Here the same force has been applied in a different direction.
Absolutely.
So, this may tilt the block. Okay. This may tilt the block. So, effect of force on a body will change with change in direction in which the force is applied. So, force for its complete expression requires magnitude as well as direction. Therefore, force is a vector quantity. Let us see what is the significance of direction. Let us consider a particle P which is initially at some point O and it is moving in a plane. And we have an additional information that from O the particle is now at a distance r from O and it has moved to some different point. Can we specify exact location of P? We have initial position, we know it is at a distance r from the initial point O.
Right.
But now is this information enough to specify the location of point P? The answer is a big no, because particle can be anywhere on this dotted circle. The only thing which we have specified is distance r from O. So, every point on this circle is at a distance r. So, if particle can be anywhere, we cannot specify its final position with this limited information. However, here the particle will be at some point, as we said earlier, will be at some point on the circle, as sense of direction is not given. In order to locate the position of the particle, we need an additional information which is the direction.
Yes.
This will be clear in the coming few minutes. Suppose we have a particle constrained to move along a straight line with respect to a point O. O is the reference point which we generally called origin. For simplicity, here in this example we have assumed that this particle is constrained to move only along a straight path. the distances to the right of O we by convention take as positive, to the left of O we take as negative. And above O distances can be taken as positive vertically above O, and vertically below we can take the distances as negative. So, this is convention. You can use different conventions, it is your choice. A particle starts from O and moves along horizontal through 2.5 meter positive distance. We have to mark the final position, which you can see in the diagram. Its P is 2.5 meters right of O. So, you can locate the exact position of P with additional information, because you have now positive sign, means we have a sense of direction towards right.
Right, yes.
Similarly, if the particle is, the distance covered the particle is -1 meter, then it will be left of O at a distance of 1 meter. Now, in a plane the position is marked in a specified in a different way. For example, here you can see position of a point P moving in a plane with respect to a reference point O, again called an origin, can be represented by an ordered pair x, y. This these students you already know, because you have been plotting the graphs for last few years in previous classes. This ordered pair x, y identifies unique position of the particle P in plane. An illustrative example: supposing we have a particle at O, starting from O and moves to a point P +2 meter -1 meter. We have to mark its final position. So, what we will do is, in this xy plane, from point O we will move 2 meter right, and because the distance y is -1 meter, that will be 1 meter downward. Here this arrow shows the exact position of the point P. Similarly, if you have a particle moving to P1 and the ordered pair associated is -2 meter +1 meter, it will mean from O it has to start 2 meter left
on the x axis.
And +1 meter means 1 meter above the x axis in y direction. So, again you can mark the final position of the particle. You can see this position in the diagram P1. Another way of specifying the position of the particle in plane is with the help of a single line, which is marked here as reference line. Initially we have taken two lines, x axis, y axis. Now we are taking just one line as the reference line. Here again O is the origin, and we want to specify the position of point P. Now again here we will be needing two things. One is distance of point P from O, marked R, and other is the angle with respect to the reference line. That angle is marked theta. For position of O you will need distance R and angle theta, that is angle POX, to define the final position of point P. R theta defines the final position P of the particle. Like xy, here we have R theta. Another way of locating the position of point in a plane. Remember, theta can be positive, negative. By convention, positive angle is in anti-clockwise rotation, and negative is in clockwise rotation. Theta can be positive or negative. Positive for anti-clockwise, negative for clockwise. Here we have a specific example: 5 centimeter 30 degree and 4 centimeter -45 degree. We can use these parameters to actually find out the position of the point. This is 5 centimeter 30 degree positive angle, and in the other diagram we have 4 centimeter and minus 45 degree P dash. Okay. So, these parameters r theta also find out the position, specify the position of the point. Now, let us take examples of scalar and vector quantities which will very clearly bring out the difference between the two. A doctor advises a patient to walk 6 km each day to stay fit. Clearly, when the patient has to walk, direction does not make any difference.
Absolutely.
The only thing is he needs to walk 6 km any direction. He may go 3 km one side back, 2 km turn right, left, any direction. So, here is the distance 6 km has no sense of direction, therefore, it is a scalar quantity.
Scalar quantity.
It has a magnitude, no reference to direction in a plane or in space.
Right.
He can even go up a hill, but he has to cover 6 km in all in a day. That is doctor's advice to that particular patient.
Right.
So, algebraic magnitude alone specifies the scalar.
Ji.
Any change in distance, supposing he adds 1 more kilometer to it, it will become 6 plus 1.
Ji.
If he someday misses it by 1 kilometer, it will be minus 1, 5 kilometers. Okay. That will specify an increase or decrease in the distance covered by the person as compared to the specified or recommended distance for that patient.
Right.
Now, another example is a doctor asks his patient to get medicines from a chemist shop which he says is 100 meters from his clinic. The patient will not be able to locate the chemist shop with this information unless the doctor says you move right, left, east, west. Here the direction will have to be specified
yes.
because you want to find out the exact location. The chemist shop can be located by a vector distance, say 100 meter east of the clinic. 100 meter east becomes a vector and we call it a displacement. So, if we do not give the direction, it is distance. Displacement is also a similar physical quantity with an additional information, that is sense of direction is included with this displacement. So, vector is specified completely with direction in addition to the magnitude. Now, let us see how can we graphically or diagrammatically represent a vector. A vector is represented by a directed line segment. The length represents magnitude of the vector on a suitable scale. Scale we have to define, we have to see suitability of the scale, which will be clear with the examples which follow.
Right.
Then direction, arrowhead drawn from initial point to the terminal point, that gives the direction of the vector. Represent a displacement of 500 meter east graphically. This is an example. Now, here 500 meter obviously we cannot draw on the paper or say blackboard. So, what we do is we take the help of a scale. Say we choose a scale 100 meter represented by 1 centimeter.
Ji.
So, 500 meter will be represented by 5 centimeter.
Right.
And then we also have conventional directions which we use in the maps.
So, yes, absolutely.
Right.
I was about to say that such kind of scales are used in maps.
Yes. Right side east, left side west, upward, north, downward, south. So, here 100 meters is equivalent to 1 centimeter. Avoid using equal to, because 100 meter is not equal to 1 centimeter.
All right.
Choose proper symbol. 100 meter represented by 1 centimeter. 500 meter will be represented by 5 centimeter. Then OP equal to 5 centimeter represents the displacement vector S. Direction is clear in the diagram itself, because it's right of O means it is east. Okay. So, this is how we diagrammatically represent a simple vector. Let us take some more examples. Represent force of 2500 Newton at 47 degree north of east graphically. That was 500, This is 2500. So, you have to choose a proper scale. Now, say we can go 500 Newton represented by 1
जी
centimeter, or say 1000 Newton represented by 1 centimeter.
जी
That will depend on the magnitude to be represented. So, here the scale in the diagram is 500 Newton represented by 1 centimeter, 2500 by 5 centimeter, and we have direction 47 degree north of east. See, this is north of east. From east you have to turn towards north through an angle of 47 degree. OP we will draw 5 centimeter, but remember our 1 centimeter is 500 Newton. So, we will not say OP is 5 centimeter, we will say it is a force of 2500 Newton,
जी
because we have represented or drawn the length according to a suitable scale. Another example where the scale required is different. So, that is why this example is different from earlier ones. Here the velocity is just 0.6 millimeter per second, very small quantity, 0.6 millimeter is very small distance. So, here we say we can take 0.1 millimeter per second represented by 1 centimeter.
right
So, to make the diagram impactful, 0.6 millimeter per second will now be represented by 6 centimeter,
जी
which will be very clearly visible in the diagram. You can see rest is clear from
So,
the
it's
diagram.
a very good example, sir, because we have always seen we decrease when we take a scale, but this is a very good example where we are increasing the value.
That is what is meant by suitability of the scale.
Right
Okay. So, it has to be chosen depending on magnitude of the quantity
जी.
being represented.
right right
Here OP represents velocity vector V. Remember, the velocity vector is represented by italicized bold letters in our convention. That is what we have already stated. These are some problems. You can try these problems and visit them later. This will give you sort of revisit into what we have studied so far. Now, for study of motion, we need two vectors, position vector and displacement vector. Sound similar, but there is a difference in the two, and we will try to bring out that difference. Two vectors often needed to describe and analyze motion of a particle are position vector, which specifies the position of the point, and displacement vector, which specifies how far the particle has moved from initial position to final position, with the sense of direction also, because it is displacement, it is a vector quantity.
right
We discuss these one by one. Position vector. Suppose a particle is at O at the start of the motion, then O is usually taken as the origin or reference point for describing the motion. Suppose the particle moves to P over a time T. Directed line segment OP represents the position vector of P, which will specify the final position of point P with respect to the origin. So, O here is origin,
जी
P is the final position, OP is the position vector of P with respect to O.
जी
Now, coming to displacement vector, OP here is a displacement vector. Why so? Because Pi is initial position vector. Here R is the reference, R is taken as origin. Particle was at O, finally it has moved to P.
okay
Okay. So, Pi represents initial position vector, Pf represents the final position vector. Position vectors are to be described with reference to R, the origin, reference point, because reference point need not always be origin O. We can define reference, choose reference point as per our convenience. So, OP represents the displacement of particle from initial position O to final position P. Directed segment OP from initial position O to final position P gives the displacement vector S. Position vector is present position and displacement vector is change from initial position to the final position. That is displacement vector. Again, it is a repetition. Position vector of a particle at an instant is always defined with respect to reference point. The reference point need not always be the origin O. That different reference point we have already chosen in our previous example. In above example, R was chosen as the reference point. RO represents initial position vector, RP represents the final position vector, and OP represents the displacement vector. Now, having talked about the scalars and vectors, now let us talk about the types of vectors. Multiply vector with a real number, let us see what we will get. Will there be any effect on direction or not when you multiply a vector? Addition of vectors, is it same as scalars or different than scalars? Triangle law of vector addition, the law is used to add the vectors. Another law is parallelogram law of vector addition. Again, we have to use these specific laws to add the vectors. Now, how to subtract the vectors, that also we will discuss. Types of vectors, first thing, equal vectors, very simple definition. Two vectors are said to be equal if they have same magnitude and they are acting in same direction, because vector has magnitude as well as direction. For equality of two vectors, they must have same magnitude and same direction. And they should obviously also be representing the same physical quantity. You cannot say 25 Newton equal to 25 meter.
All right.
The vectors will be equal, only both the vectors represent the same physical quantity.
Right.
Negative of a vector B is equal to vector B, but in opposite direction. Here you can also say that the vector has been multiplied with negative number -1. So, when you multiply a vector with a negative real number, the direction is reversed.
Right.
These are equal vectors. Here B is minus A or A is minus B. Each vector is negative of the other vector. Modulus of a vector. Modulus means you delete the direction, you talk only about the magnitude of the vector. So, modulus of vector A means is a scalar quantity because we have
no direction.
We have deleted the sense of direction.
Right.
We write modulus of vector A as symbol A, because for vector we use a italicized bold, and here there is a sort of inaccuracy in this symbol. These have to be vertical lines. The vector A symbol has to be within vertical lines. That is what signifies the modulus of the vector A. Here, if vector A is 75 units east, the modulus will be 75 units.
Right.
You just have to drop the direction. Unit vector of a given vector A, as the name suggests, it will have a magnitude of 1 unit only, and the unit vector is the vector A divided by its magnitude. 75 Newton east divided by 75 Newton, you will get only direction here, east. Okay, 1 unit east. That is what unit vector of vector given vector F will be. Unit vector is written as A cap. You can see there is a small symbol here,
dash,
A cap. We call it cap or hat. Okay, A hat. It is vector A divided by its magnitude, read as A cap, A hat, A caret. Unit vectors along positive x direction, positive y direction and positive z direction, they have been allotted special symbols I cap, j cap, k cap. The symbols are here on I cap, j cap, k cap.
Right.
And if they are in negative directions, then we will have to take minus I cap, minus j cap, minus k cap. Fixed vector or localized vector. A vector is said to be fixed or localized if it has a fixed initial point. Okay? For example, you can take a horse tied to a particular peg. He is applying a force. That force has its origin at that particular point, initial
yes,
point.
yes.
Such a vector will be called a fixed vector. The reference point is always a fixed point. Free vector is a vector which is free or non-localized. It moves from one place to another. Say for example, a horse is pulling a cart. In that case, the force is not a localized vector.
The initial point is changing.
It's the application point of application is changing. It's free and non-localized vector in motion.
Right.
Initial point not fixed. Constant velocity vector of a car on a straight track is another example of free or non-localized vector. Collinear vectors. Two vectors are said to be collinear if they act along same line or parallel lines. Parallel lines because all parallel horizontal directions are east. Okay, so we consider them to be same direction or collinear vectors. Like vectors, two collinear vectors are like if they act in same direction. That is, angle between the vectors is 0 degree. Here you have a diagram. Magnitude may or may not be equal, but the direction has to be same. Only then the vectors will be like vectors. Similarly, we have unlike vectors. Here in this diagram, the vectors are unlike, parallel, but in opposite directions. These are unlike vectors. Again, magnitude may be equal, may not be equal. Coplanar vectors, as the name suggests, they must be acting in the same plane. Co-initial vectors, again very simple, they should have a common initial point.
Yes.
Here we have three vectors A, B and C with a common initial point P. They are all called co-initial vectors. Similarly, we have coterminous vector which terminate at a common point. See this, vectors A, B and C terminate at P.
Okay.
For example, if you must have seen people sometimes when a tent is erected, there are a number of workers who hit a peg
yes.
at a particular point. So their forces are coterminous because they are terminating at the same point.
Right.
Such vectors are coterminous vectors. Zero vector or null vector has zero magnitude. That is what a null vector or zero vector is. It is represented by bold, zero, italicized as per our convention. There are some properties, specific properties of zero vector or null vector. Vector A plus 0 vector is A. It will not make any effect because a force of 5 Newton, another force of 0 Newton means the net force will again be 5
Newton. Yes.
Multiply a number with 0 vector, magnitude will continue to be 0 and 0 vector has any arbitrary direction. You can say east, west, north, upside, downward because force of 0 Newton, any direction you like you can assign it. There is no force acting. So, any direction you can assign, it is immaterial.
Right.
If m into A equal to n into B, A is a vector, B is a vector and they are equal, m is not equal to n, but you have m into A equal to n into B. This will always imply that the two vectors are zero vectors are null vectors. Otherwise, MA cannot be equal to NA. Now, multiplication of a vector with a real number. For a real number n into vector A is a vector whose magnitude is n times. For example, if there is a force of 10 Newton and you want force F of 10 Newton east, you want 7F, it will be 70 Newton, will continue to be in the same direction, that is east.
East, yes.
Direction same for n greater than 0. Alternately, if n is negative, then the direction will be
West.
reversed.
Yes, of course.
The direction is reversed if n is a negative number. Example, supposing we have a displacement 200 meter south, then 7s will be 1400 meters south, same direction, because 7 is a positive real number. Coming to vector addition, the addition and subtraction of vectors is different from that of scalars. It does not follow the laws of scalar addition. To appreciate the difference, let us subject a particle to two different displacements one by one. First displacement is 4 meter east, second displacement is 3 meter north. The net displacement, is it 7 meter? Let us check.
Right.
We will probe it and see if it is similar to scalar addition or something additional comes up here. Let us represent 1 meter displacement by 1 centimeter. We will draw it diagrams to explore this. The given displacements are represented by OA and OB. OA here, this is 4 meter, this is 3 meter. The initial position is O. The particle moved to A because of S1, moved to B because of S2. Now, the displacement final position is specified by B with respect to O. So, you can see here net displacement is OB because it has to be measured from O, which clearly will be less than S1 plus S2 because straight line happens to be the shortest distance between 2 points. So, had these been scalars, 4 plus 3 would have been 7.
7, right.
Here 4 meter east plus 3 meter north is not 7, it is less than 7 meter.
Okay.
So, vector addition is different from scalar addition. You can find out OB by Pythagoras theorem, which you know from your knowledge of mathematics in previous classes. The net displacement will be 5 meter from O to B, and direction also you can actually check diagrammatically. You can measure the angle here at O. This angle will give you the direction, provided you have drawn a geometrically correct diagram. By geometrically correct diagram, I mean OA should exactly be 4 centimeter, AB should exactly be 3 centimeters. OB will come out to be 5, and then direction also will be given by the diagram. So, vector addition is different from scalar addition. This is our conclusion. Now, how to add the vectors? First, starting with very simple cases, vectors along same line. Here again we have two sub cases. They may be in same direction, they may be in opposite direction. Same direction, the resultant or net effect will be sum of the two vectors. You move 4 meter east, and
3
then
meters
move
further
3
east.
meter further east. Net displacement from the starting point will be 7 meter east. Direction will be same because both the vectors have same direction. Opposite directions, resultant will be difference of the two. And what about the direction? You can guess it will be the direction of the larger of the vectors.
Of course.
Yes, larger of the vectors. Two forces acting on a body are 50 Newton east, 35 Newton east. The net force will be
50 Newton east and 35 Newton
east.
85 Newton east.
East, yes. So, simple addition.
Yes.
Provided vectors are in same direction.
Yes, of course.
And along same line.
Yes.
85 Newton east is the resultant or net force. If we have 50 Newton force north,
North.
and 35 Newton south, then the net force will be
15 meter north.
15 meter north. The direction will be that of the larger of the two vectors. See here, the sign is positive, you are adding the vectors, but magnitudes have to be subtracted because of the direction.
Right.
So, vector addition and scalar addition, they are different. Now, vectors at right angles, easy to add because here Pythagoras theorem can be applied. This we have seen in previous example, AC square is AB square plus BC square. So, here we are adding two vectors AB and BC. The net or resultant vector is AC.
AC.
The direction, as we said earlier, we can find geometrically or even mathematically. Now, how to get the direction mathematically will be clear with an example. We have a particle subjected to two different displacements. Similar example we are continuing, so that we get a clear idea of how different
determine the
methods
direction.
lead us to same result. 4 meter east, 3 meter north, we have to calculate the net displacement. We choose 1 meter represented by 1 centimeter, draw the diagram. You have the resultant or net displacement SOB in the diagram, 5 meter it will be, and angle you can measure with the help of a protractor. As I said earlier, if the diagram is appropriate, the direction will also be appropriate. So, this OB will give you not only the magnitude, but also the exact direction. So, this is how we add vectors, different from that of scalar addition. Applying Pythagoras theorem, OB comes out to be 5 meter, direction geometrically or mathematically. Mathematically, in the diagram you can see tangent theta is AB over OA, perpendicular over the base. So, you get tangent theta equal to 0.75. Theta we can find from the trigonometric tables.
Right.
So, here the resultant will be 5 meter theta degree north of east, as you can see in the diagram. Tangent inverse 0.75. Case 3, it is the most general case, vectors at any angle. There are rules of adding or subtracting vectors. They are different from the scalar addition. You can see we have two laws, parallelogram law of vector addition and triangle law of vector addition. We will talk about one law in detail, others are similar and they lead us to same result. Triangle law of vector addition, two sides of a triangle taken in order represent two vectors. We have two vectors to be added. First vector will be represented by side number 1, second will be represented by side number 2. There is a method which is very clearly outlined in the statement of the law. Let us read the statement very carefully. If two sides of a triangle taken in order represent magnitude and direction of two vectors to be added, the third side or closing side of the triangle taken in opposite order, this is written in bold, it has a meaning, represents the magnitude and direction. Rest it will be clear when we actually take an example. Taken in order implies terminal point of first vector to be added is the initial point for the second vector. So, where first vector ends, you will draw the second vector, and the resultant is in opposite order. First vector AB, second vector BC. AB, terminal point of first vector, is starting point for the second vector. Resultant is AC in opposite order. In order will mean AB, BC, CA.
Right.
AC is in opposite order.
Right.
So, resultant has to be taken in opposite order.
Right, right.
Okay. Parallelogram law is similar. If two vectors acting simultaneously on a particle are represented by two sides of a parallelogram drawn from a point, both vectors are to be drawn from same point, then the diagonal of the parallelogram drawn from the same point gives the resultant. So, here all three vectors P and Q to be added and resultant R, they are to be drawn from the same point.
Okay.
They will all be co-initial.
Right.
These are the vectors to be added. Parallelogram law, OA represents P, OB represents Q. Both vectors are represented from common point O.
Yes.
Then you complete the parallelogram. The diagonal OC gives the resultant.
Right.
The diagonal is to be drawn from the same point O. Compare with triangle law, AB plus BC, that is vector P plus Q gives R. So, you can see from the diagram these are of equal length and they are in same direction. Irrespective of the law that you apply, the resultant will be the same.
Right.
This is the repetition of what you have studied earlier. Triangle law,
Right.
beta here gives the direction. So, R gives magnitude as well as the direction. If you draw the vectors correctly diagrammatically, then resultant R will also be correct. You can measure it geometrically with the help of the scale, you can measure beta and that will also give you the direction.
Ji.
Same with parallelogram law here. Here again in this diagram, beta angle will give the direction. Okay. So, if you compare triangle law application and parallelogram law application, the resultant will come out to be same magnitude as well as the direction. Now, this is geometrical method of adding the vectors.
Ji.
In our next lesson, we will be talking about an analytical or mathematical method by which we can actually get the magnitude of the resultant of two vectors either by triangle law or by parallelogram law. Both magnitude and direction will be mathematically represented.
Right.
We will discuss it in our next lesson.
Right. All right. So, that was really an amazing chapter that we did with Shri I.K. Singh sir, and dear viewers, I would like to tell you, I did not study vectors when I was in the school, but I am very clear with the concepts, all the concepts like scalar and vector, quantities, types of vector, addition of vector, subtraction of vector. दर्शकों, अगर आपसे कुछ कोई कॉन्सेप्ट छूट गया है, do go back to our YouTube channel, revisit all those concepts and I am sure they are going to help you a lot in your board classes. तो दर्शकों, हम इसी तरह से एक अनोखे अंदाज में आपके लिए लेकर आते हैं वही चैप्टर्स जो आप अपने स्कूल में पढ़ते हैं, लेकिन बहुत ही फन और इजी वे में आप तक पहुंचाने का प्रयास किया जाता है. दैट वाज Shri I.K. Gogia sir with us, and I would like to give my thanks to sir. Thank you so much for being in this session.
Thank you so much for
Ji.
giving me a chance to talk about the
Absolutely, it was
subject.
our pleasure, sir.
Same here.
Ji, it's time to wrap up the session now, dear viewers, with an important information. The new textbooks for class 4 and 7 are available on Flipkart, Amazon and our official website of NCERT. Please get those new textbooks from there. And also I would like to tell you our next session, upcoming session is for subject biology for students of class 12th. Don't miss this session as well, because we are going to bring some very interesting concepts for you, and the topic that we are going to discuss would be the molecular basics of inheritance part 1. And with this, I, your host Anugupta, taking your leave. Namaskar.